Now this is the figure to demonstrate that what happens if we put a trip wire. Generally we have this concept of wire which is placed, this is the wire of given some diameter, it is placed horizontally on this flat plate. This is a two-dimensional figure. This is a surface plate, solid plate, kept stationary, velocity of this plate is 0 and fluid is coming in this direction with velocity v. Then what happens, initially when Reynolds number is less, we have a laminar boundary layer, and because of this wire we have a mixing of the fluid in transverse direction. Basically transverse component of the velocity is developed because of the presence of this trip wire. This is known as trip wire. The function of the trip wire is to convert laminar boundary layer into turbulent boundary layer early. If we don't put this trip wire, then also this laminar boundary layer will be converted into turbulent boundary layer, but it will take its own distance. If we put this trip wire, then this transition is fast, means turbulent boundary layer is initiated early, and this concept is used at several locations. When we shall talk about the separation, we will discuss the importance of trip wire, which is responsible to convert laminar boundary layer transition into turbulent boundary layer very early. Now in these two figures we can appreciate the laminar boundary layer and turbulent boundary layer. In the first figure we have a boundary layer which is shown in y direction. Here we have a y direction. This is the delta thickness at given location of x, and here we have velocity u. Since we know that turbulent flow is unsteady of nature, and at a given instant if we observe, then we will find these are the velocities at a given location and at different time we will find. But if we do the averaging, then we will get this thin line. This is the thin line. So about this thin line we have fluctuating component, and if we do the averaging, then we will get this value. So this is the average value of velocity inside the boundary layer, means from 0 y is equal to 0 to y is equal to delta. This is the velocity profile, average velocity profile. But if you talk about the turbulent velocity profile, then turbulent means it is unsteady in nature, right? And if we want to compare the laminar and turbulent at a given section, then if we draw the dimensionless terms, here we have a y over delta which is dimensionless term, y is the distance, delta is also distance, so distance divided by distance is a dimensionless term, and u divided by u. In the dimensional and model testing we studied that why it is important to do the dimensional analysis in fluid mechanics. With the help of doing dimensional analysis, it's easy to conduct the experiment and it's easy to analyze the result also. So if we plot graph for laminar velocity profile and the turbulent velocity profile inside the boundary layer, then y over delta on y axis and this u over capital U on abscissa. So in case of laminar velocity profile inside the boundary layer we have this variation, and in case of turbulent it is very sharp. It is almost starting, though it is starting from 0 because here it has to be 0. When y is equal to 0, velocity has to be 0, right? And in this case it is almost starting from here. It is very sharp in nature.